If someone were to ask me what I thought was the most important system in our body, I would have a tough time answering that. But I'm a little bit partial towards the circulatory system. We need them all. Without any of them, our daily lives would be completely hampered. However, the circulatory system links them all together. It transports nutrients for our digestive system, it transports hormones for our endocrine system, it controls our body temperature, it does so many things, including even helping us get rid of waste by delivering nitrogenous waste to our kidneys for excretion. So the circulatory system is extremely important. We wouldn't survive without it at all. I've taken the liberty to draw a couple of pictures here to show you the circulatory system. The advantage is obviously that it takes a lot less time for me just to hang them up than it does to actually draw them, and they're probably better this way than if I was to draw them in front of you. This diagram represents the circulatory system in a very simplified fashion. We have the lungs up here. This is the trachea. This is the heart here. This is a capillary bed. A blood vessel like this one would be an artery. A blood vessel like this one would be a vein. In one of the upcoming videos, we'll spend a lot of time dealing with the structure of arteries and veins and capillary beds and exactly what their functions are. But for now, we're just going to look at this system here in a simplified fashion. The heart's in the middle of it. I'm going to put left atrium here, left ventricle there, the four chambers of the heart, right atrium here, right ventricle there. I'm color coding it. Normally we think of oxygenated blood as being a brighter red than deoxygenated blood. The right side of the heart only ever has deoxygenated blood in it. The left side of the heart always has oxygenated blood in it. And I might point out that this is the left side of the heart, but if you think about it, if you're looking at it, that's on your right side. This is as if it were my heart, and that's my left side, so that's how that heart is labeled. To follow along with this a little bit now, the blood in the left atrium will travel down into the left ventricle, up through this blood vessel, around, you can see around here, that's an artery. This is actually the aorta, the major artery. That takes it to a capillary bed. This capillary bed could be anywhere in your body. It could be in your foot, it could be in your stomach, it could be anywhere in your body. It's just somewhere that's not your lungs. Once the blood's through the capillary, it enters a vein, is conducted back up to the right atrium, flows through the heart into the right ventricle, up this blood vessel. This is the pulmonary artery, and the pulmonary artery takes it up. Notice it splits, divides to the left and right lungs, so we have a left pulmonary artery and a right pulmonary artery. The function of the lungs is to oxygenate the blood, and the oxygenated blood, now using red again, comes out of the lungs and re-enters the heart in the right atrium. Recognize that for every time the blood makes one complete circuit of the body, it's gone through the heart twice. For every complete circuit, it's gone through the heart twice. That's why we call it a double circuit. It's a double circuit. We have a pulmonary circuit. Pulmonary dealing with the lungs only, exclusively. And we have a systemic circuit. Dealing with the systems. Notice one other thing, that in both of these we have oxygenated and deoxygenated blood, because pulmonary circuit would actually begin down here in the right ventricle, and it takes the blood to the lungs, and from the lungs it goes back to the left atrium. In the systemic circuit, we start with the left ventricle. It takes it out to some system, some capillary bed in a system. Where it delivers its oxygen and takes it back to the right atrium. Right atrium. So my point is that in both the pulmonary circuit and the systemic circuit, we have deoxygenated blood and oxygenated blood and deoxygenated blood. We have to look more closely at the heart itself. So let me change pictures. Put this one up. And I'll draw your attention to these features. But first, let's go through the heart structures itself again. We have, just so you get oriented to this picture, the left atrium, left ventricle, right ventricle, right atrium. The pathway of blood through the heart from the right ventricle through these are valves. We'll talk about valves in just a second. This is the pulmonary trunk. The pulmonary trunk divides to go to the left lung and to the right lung out here. From the lungs, the blood comes around, it's oxygenated when it comes around back into the heart. It comes in here. Notice there's two blood vessels. And that's into the left atrium then. From the left atrium it goes down to the left ventricle, through this valve, then through that valve, out into this, which is the aortic arch. The aortic arch delivers it to the body itself. It goes down here, dorsal aorta, into your kidneys and your intestines, and down your legs and your iliacs, all that. Up here the aortic arch has its own branches. These branches go up to the head region. There's actually four of them here. The inner two are the carotids. They go up your neck into your head. These two on the outside are subclavians. They go out into your shoulder, your upper chest, and your arms. When the blood's gone out through into the body, that's the systemic circuit now, and it's in some capillary bed around the body. It will come back to the heart in a deoxygenated fashion. So it'll come back up here if it's in the lower part of the body, or it'll come in here if it's in the upper part of the body. These are called the vena cavas. We have a superior or anterior vena cava up here coming down from the upper part of the body. We have an inferior or a posterior vena cava coming from the lower part of the body. Vena cava simply means big vein. Those are the biggest veins in the body, like you think of cavity or cave, vena cava, like that. And the blood, once it gets into there, into the right atrium, comes through here, out here, into the right ventricle, and around there. That's the pathway of blood through the heart. Again, let me point out, this side of the heart deals with oxygenated blood. This side of the heart deals with deoxygenated blood. Another feature of the heart that we have to point out is this structure right here. It's a septum. Septum just means a wall. It's a wall that divides the ventricles from each other, keeping the blood, oxygenated blood, separate from the deoxygenated blood. We have other septums in our body too, like the septum in your nose. If you have a broken nose, that's technically a deviated septum. The thickness of this black line here represents more muscle tissue. The ventricles are very large, strong muscles, and in comparison, notice the walls of the atria are quite a bit smaller, so they're not as muscular as the walls of the ventricle are. I want to point out the last feature of the heart, and that's these valves. There are valves in various places in the body. The valves in the circulatory system prevent the backflow of blood. It would not be good if the blood could get from the left ventricle back into the left atrium, or from the right ventricle back up here. It's a one-way flow pattern. It can't go the other way. So what happens, quite simply, when the pressure, say in the left ventricle here, is greater than the pressure in here, that valve closes. And what it is like two trap doors. If I just represent it like this, and this has got increasing pressure, it just pushes those things up and they lay flat. So it closes that opening. In the heart there are 4 valves. These two here are AV valves. AV, this one, and that one. AV valves stands for atrioventricular. Because they're between the atria and the ventricles, AV valves. These things, technically, they're cuspid valves. Now, the naming of valves gets a little bit awkward. When we talk about them as being AV valves, that's talking about it with reference to their location. Cuspid valves is a term that's describing their shape. It's because a cusp is a smooth surface like that. We have 2 cuspid valves. We have 2 AV valves. We have a tricuspid and we have a bicuspid. The bicuspid valve is also called the mitral valve. Which one is which? This one is on the right side of the heart. That's this one here, the tricuspid valve. This one is the bicuspid valve. It is also known as the mitral valve. The other 2 valves are called semilunar valves. That's this one here and this one here. They're at the beginning of the arteries. This is the beginning of the aorta, beginning of the pulmonary artery. And they're simply known as the pulmonary valve and the aortic valve. Again, the names here, these names, pulmonary and aortic, are more with reference to their location. Semilunar valve describes more of their shape, same as this was a locational label and this is a shape label to them. Well, that wraps up our look. Oh, wait a minute. We've got one more thing I just about forgot. One more feature very, very important in the heart. And I scribbled all over my picture, but I think I can show you. I'm going to draw some lines down here. These lines are tendons. There are actually tendons inside the heart that prevent the valves from flipping backwards. You can imagine, I'm sure, that if this pressure in this valve, this chamber, or this one, got very high, these valves are going to be pushed shut, so they seal off that opening. But if they could flip open, then the blood could actually be moved from the ventricle into the atrium, and that would be disastrous. These tendons are called chordae tendineae. What they do, quite simply, is they prevent, we're going to put it this way, AV, because we're talking about atrioventricular valves, valve inversion. They prevent the valves from becoming inverted. Again, they're preventing the backflow, which is a general function of all valves. Now I think that wraps up our look at the heart for now. In a future video, we'll look at the heart one more time, but in terms of fetal circulation. Thanks very much.